This video is going to explain some practice problems for exponent rules. So I have my notes already completed, and I have on this notebook piece of paper. So what I'm going to do is open up my notes, and I see that there are 38 practice problems. So I'm going to try my best to put all the answers on here and showing work, but if I don't have enough space, what I'm going to do is I'm going to turn my notebook page to the back and just turn this over. And any problems that I need to show extra work for, I'm just going to write down on here. Okay, so I'm going to go ahead and come to this first problem. These are just example problems. So the first example is, we're just simplifying. This is 3 times 4 to the third power. Now, since these are all just numbers, you can actually just plug these into your calculator because there's no variables. 3 times 4 to the third. 4 to the third power is actually 64. And then we multiply it by 3, and you get 192. So this is equal to 192. There's nothing that you actually have to show for that, because those are just numbers. You can plug those in your calculator. Now, for example 2, we have numbers and letters. We're multiplying. So we have numbers. 4 times 2, you multiply numbers like normal. So 4 times 2 is equal to 8. But then we have the bases of x and x. Since they have the same base, we can add the exponents, because again, this is the product rule. X times x means we're going to add the exponents. So it'll be x raised to the 3 plus 3 is 6. Example 3 is x to the 5th times x to the 3rd. So again, we're multiplying bases. We add the exponents. Keep the base of x raised to the 5 plus 3 is 8. Example 4, we have 2x cubed times 2x squared. Again, you take your 2 times 2, numbers are just numbers, so you multiply like normal. 2 times 2 is 4. Then we have x times x, so we're going to add the exponents. We're going to keep the base of x. We're going to add the exponents. 3 plus 2 is 5. On number 5, we have 6 to the 5th divided by 6 cubed. Well, since we're dividing, we have the same base. We keep our base. The 6 to the 5th is bigger, so that means our 6 is actually going to stay on top of the problem. So we're going to have 6 raised to the power of, we subtract the exponents, was 5 minus 3 is 2, so it's 6 squared. Well, 6 squared is they're just numbers, so that's equal to a positive 36. On example 6, we have x to the 4th divided by x to the 7th. So again, division, we're going to subtract our exponents. We have the same base, so we keep our base. Now this was talking about where is the exponent bigger. X to the 7th is actually bigger, so that means we're going to keep our x on the denominator. That means we're going to have a division. We're going to have x in the denominator. Since x is the only letter in here, that means that 1 actually has to stay on the numerator because there's nothing else to be up there. So you have to keep the 1. Now, for the exponent, we still do 7 minus 4. We don't have to worry about the negatives. Wherever your exponent is bigger is where you start. So it's still 7 minus 4, which is a positive 3. The reason I do this is because if I did 4 minus 7, I'd get a negative 3, and then I would have to move it, and I don't want to have to worry about that. So it's 1 over x cubed. Number 7, 8 to the 0 power. Again, any base except for 0 raised to the 0 power is automatically 1. So 8 to the 0, this 0 is attached to that 8. So all of that becomes 1. On number 8, we have negative parentheses 9x parentheses raised to 0. So again, this 0 is attached to this 9x, to this parentheses right here. So this section is equal to 1. But that negative on the outside is still there. So that's really a negative on the outside. Negative on the outside. Then all of this becomes a 1. So it becomes a negative 1. So again, that's why I was saying be careful about what is your exponent attached to. You have to be very clear about where the exponent is attached. On number 9, we have y to the 4th raised to the 3rd power. So again, we have one base, so we multiply the exponents. So it's 4 times 3. This is y to the 4 times 3 is 12. On number 10, we have an expanded power rule, so we have an exponent on the outside. This 4 is attached to everything inside the parentheses. So we have an exponent and another exponent, so we're going to multiply those. So we keep the base of x, and we multiply the exponents. That becomes 2 times 4 is 8. Then we still have a base of y attached to it as well, but the exponent on the y is a 1, so we have 1 times 4 is 4. On number 11, we have division. We have numbers divided, so 6 divided by 2. You can actually go ahead and simplify that. That is 6 divided by 2 is 3. Now, we have, again, the bases, 2 bases that are dividing, so we do want to subtract, but find where your base is, or your exponent is bigger. It's x to the 7th divided by x to the 4th, so the 7 is bigger. That means our x is actually going to stay in the numerator of the problem. It's going to be 7, the bigger number, minus 4. So 7 minus 4 is 3, so it's going to be x cubed. On number 12, we're going to do the same thing. It's division. We have 8 divided by 4. Those are numbers. So 8 divided by 4 is just 2. Then we have the same bases, so we're going to divide those by subtracting the exponents. X to the 5th divided by x squared. 5 is bigger, so that means that the variable, the base is going to stay in the numerator. It's going to be 5 divided by 2, which is 5 minus 2. That means we're going to have 3. So 2x cubed. On number 13, this looks like it's going to have a little bit more to do, so I'm probably not going to have room on this page right here. So what I'm going to do is I'm going to take number 13. I'm actually going to write it on the back of that page when I turn it over, so I can actually show some more work. So I'll zoom out a little bit here. I'm going to put number 13 again. I'm going to write number 13 out. Number 13, I'm going to put it up here, was parentheses 2c d to the 4th, parentheses all that raised to the 2nd power, then times, so parentheses c d, close parentheses, raised to the 5th power. I want to make sure that I know that this is multiplication. I have an exponent on the outside of this first set of parentheses. I have an exponent on the outside of the second set of parentheses. So I got to make sure I do it's the expanded power rule. So I'm going to have 2 raised to the 2nd, because this has a 1 right here, this has a 1, this has a 4. The exponent has to go to all the exponents in the problem. This becomes the base of 2 raised to the 2 times 1 is 2. The base of c raised to the 1 times 2 is 2. The base of d raised to the 4 times 2 is 8. Times, again, I have an exponent on the outside, so I have a base of c raised to the 1 times 5 is 5. I have a base of d raised to the 1 times 5 is 5. And now we just look to see, do we have only one letter C in the problem? We don't. We have multiple. Do we have one letter D? We don't, so that means we have to simplify those. And we also see we have 2 squared. Well, 2 squared is just a number and an exponent. That means we can simplify that. So 2 squared becomes 4. That's the only number in the problem, just actual number, so it becomes 4. Then we have c squared times c to the 5th. Well, these are the same base, so we have the same base of c, and we add the exponents. 2 plus 5 is 7. Then we have 2d, so we're going to put the base of d. Then we're going to add the exponents, because it's multiplication. 8 plus 5 is 13. So our answer for number 13 is 4c to the 7th, d to the 13th. We'll write that out here. 4c to the 7th, d to the 13th. Number 14 looks very like number 13, so I'm probably not going to have enough room on here, so I'm going to write number 14 down on my paper as well. So number 14, I'm just going to write it beside here. 14 is parentheses 2f g to the 4th, close parentheses, raised to the 4th power, times parentheses f g parentheses raised to the 6th power. So again, we're going to make sure we're careful on our exponents on the outside of the problem. Exponents on the outside of the problem. So this exponent goes to all of the exponents inside, so that includes all the bases, 2, f, and g. So this becomes 2 raised to the 1 times 4 is 4. Base of f raised to the 1 times 4 is 4. Base of g, 4 times 4 is 16, so raised to the 16th power. Times, because that's in the middle here, base of f raised to the 1 times 6 is 6. Base of g raised to the 1 times 6 is 6. And again, we look to see if we can simplify it further. Since we have an f on this set and f on this set, that means we do need to simplify it further. 2 to the 4th is a value, so we can actually simplify that. There's no other number in here to multiply it by, so it's just going to be 2 to the 4th. 2 to the 4th is 16. Then we have f in the first set and f in the second set. So that means we're going to have a base of f. We're going to add them. 4 plus 6 is 10, so it's f to the 10. Then we have a base of g. Since we have 2 of them, we have to add the exponents. So 16 plus 6 is 22. Now, we have no number with an exponent because it's just 16. We have one letter f and one letter g written. So then that would be our answer. So on number 14, I'm going to write 16 f to the 10, g to the 22nd. So on number 14, 16 f to the 10, g to the 22nd. So moving on to number 15. 15 looks like I can probably do it on this paper. It is division. It's x to the 5th divided by x. The x to the 5th is bigger, so we're going to keep the x on the top. And it's going to be 5 minus 1 is 4. Then we have a base of y. It's y to the 6th divided by y squared. The 6 is bigger, so the base will stay on the top. 6 minus 2 is 4. So it's x to the 4th, y to the 4th. On 16, we have division. Again, x squared divided by x. The 2 is bigger, so x is going to stay on top. X to the 1st, because 2 minus 1 is 1. Then y to the 5th divided by y to the 4th. The 5 is bigger, so y will stay on top. 5 minus 4 is 1. So you can write this as, this is the same thing as saying x, y. That means the same thing. 17 actually has multiple parts to it, so I'm probably going to do this on a separate, this paper back here as well. So number 17, I'm going to zoom out some so you can see the work. Number 17 is parentheses 4x to the 5th y divided by 16xy to the 4th, and all of that raised to the 3rd power. Now, instead of just going ahead and distributing the 3 to everything, what I'm going to do is simplify the inside first, because this is not negative. If you simplify the inside first, it makes things a little bit easier, and you don't have to multiply as much. So let's go ahead and start with our numbers. 4 over 16. 4 divided by 16, so I put in my calculator. 4 divided by 16. It is a decimal, so I hit math, enter, enter, and it gives me 1/4. So make sure you always simplify your fractions. It's 1/4. So I have parentheses 1/4, and it is still a fraction, so I put the 1 on top, 4 on the bottom, and that'll help me in case I need to have a numerator and denominator for my variables. I go to the x's. The 5 is bigger, so the x will actually stay on top, so I keep my x. And then I have 5 minus 1 is 4, so it's x to the 4th on top. Then if we look at the y's, the y is bigger on the bottom, so that means I'm going to have y on the bottom of my fraction, my denominator. And I still do 4 minus 1. I still do big number minus little number, so 4 minus 1 is 3. Close parentheses, all raised to the 3rd power. Now I have less that I have to multiply. So what we have to do is make sure we take this 3, the exponent of 3, multiply to every single exponent of each base. So there's a 1, an x to the 4th, a 4, and a y to the 3rd. So all of these have an exponent. So again, it's 1 raised to the first power, 4 raised to the fourth power, x to the fourth, y to the third. So when we distribute this, when we take this exponent of 3, it becomes 1 raised to the third power. Then we have x raised to the, we multiply 4 times 3 is 12. Divided by, we do the bottom, so it becomes 4 is your base, raised to the 1 times 3 is 3. And then we have a base of y, and we do 3 times 3 is 9, raised to the 9th power. Now the only thing left to do is any numbers that have an exponent with it, you got to simplify that. 1 cubed is 1, 4 cubed is 64. So it's 1 over 64, which that can't simplify. So this is equal to 1 x to the 12th divided by 64 y to the 9th. Because we can't simplify the x and the y's any further. So number 17 is equal to 1 x to the 12th over 64 y to the 9th. And you could just put x to the 12th in the numerator. If you have just x to the 12th in the numerator, that's fine. So 18 looks very similar to 17, so I'm actually going to write 18 on the paper as well and do the work there. So number 18, write it out over here. 18 is parentheses, big parentheses, 5x cubed y divided by 20x y to the 5th, and all of that raised to the 4th power. So I'm going to follow the same steps I did on number 17. I'm going to simplify first. 5 over 20. 5 over 20 is also 1 over 4. So I have 1 over 4. X cubed divided by x. X is bigger on top, so it becomes x to the second on top. Y is bigger on the bottom, so I have y on the denominator. 5 minus 1 is 4. All of that raised to the 4th power. So again, in this light blue, we're going to have that 4 is going to be multiplied to every exponent in the problem. So it becomes 1 to the 4th, x to the 8th, all over 4 to the 4th, and y to the 4 times 4 is 16. Now the only thing left to do is to simplify this. So we have 1 to the 4th is just 1. 4 to the 4th is 256. So we're going to have 1 over 256, which doesn't simplify. This is 1 x to the 8th over 256 y to the 16th. I'm going to write that on my paper. I can write it as just x to the 8th over 256 y to the 16th because that, this x to the 8th over 256 y to the 16th because this 1 is technically still there even though you don't see it. So it'd still be 1 over 256. So be careful. That's not just 256. That is 1 over 256. On number 19, it's y to the negative 7th. Well, the negative 7 is attached to that y. So this becomes 1 over y to the positive 7th. On number 20, this is 7 to the negative 2. 7 to the negative 2, really, you have to change that to become 1 over 7 squared. But 7 squared is 49, so this becomes 1 over 49. So again, this 7 to the negative 2 has to go to the denominator, so it becomes 1 over 7 squared to a positive 2. 7 to the positive 2 is a 49. On 21, we have 1 over x to the negative 5. That x is attached to that negative 5. That needs to move. Since it's on the bottom, it needs to move to the top. So that becomes a 1 times, it'll be x to the positive 5, which you can just put as x to the positive 5. On number 22, we're going to do the same thing that we just did here. We're going to take that 2 to the negative 4 and move it to the top. It becomes 2 to the positive 4. Now this is 1 times 2 to the 4th. 2 to the 4th is 16. So it's 1 times 16, which is just equal to 16. On number 23, we have a base times a base of the same basis, so you can actually add the exponents. You don't have to worry about the negative exponent right now because you can actually just combine them. This is 5 plus a negative 1, so it's 5 minus 1 is 4. So this just becomes x to the 4th power. And you don't have to worry about any negatives on that one. On number 24, x raised to the negative 6, that negative 6 is attached to that x. So all of that has to go to the denominator. What's left in the numerator is a 1. It becomes 1 over x to the positive 6. On number 25, we have x times x again, so we're going to we're going to add our exponents. Again, don't worry about the negative right now. This is 9 plus a negative 7, which is a positive 2. So this is equal to x squared. Again, you didn't have to worry about the negatives because we were adding them. Number 26, now this one looks like a bunch, but they're actually the same letters. So you're really just multiplying. This is j times j times j. So what you do is actually add the exponents. It's the same as if we were doing number 23 and 25. Here we're adding the exponents. So it's negative 13 plus 4. Negative 13 plus 4 is negative 9. And then we have to add that 6 to it. So we really have j to the negative 3rd power. So I'm going to write that down real quick. This is really j to the negative 3rd power, which we can't have because we do have to have a positive exponent. So this j to the negative 3rd, this entire thing will go to the denominator. This is equal to a 1 over, because there was nothing in the numerator, so we have to put a 1. It'll be j to the positive 3rd power. So we didn't actually have to write out a whole bunch on that one. It's just adding their exponents. On example 27, if you notice that both of these have a negative exponent, so what really happens is that they both have to move. This becomes x to the positive 8 over x to the positive 1, because they both have to move. So now it's just subtraction of the exponents. This becomes x to the 8 minus 1 is 7. On number 28, the 52 divided by 13 are numbers. So 52 divided by 13 is equal to 4. So we will have a 4 here. But do you notice that the x to the negative is x to the 6 divided by x to the negative 7? That negative 7 would want to come to the top. So we would have x to the 6 times x to the positive 7. That means we would add our exponents. So 6 plus 7 is 13. So it would be 4x to the positive 13. We do them separately. We do the numbers, then we do our variables. Don't try and do this as one huge problem. On number 29, 29 and 26 actually look very similar. It's f, f, and f, where it's all multiplication. That means we're just adding the exponents. Negative 3 plus 2 is negative 1, and then plus a negative 3. So negative 1 and then negative 3 is a negative 4. So this is really f to the negative 4, which we know we can't have a negative exponent, so this becomes 1 over f to the positive 4. Number 30 and 27 look very similar. They both have negative exponents, so we can actually switch those real quick. Becomes x to the positive 9 over x to the positive 4, because it was x to the negative 4 divided by x to the negative 9, so they both have to flip. And this is just equal to x to the positive 5. Because the 9 is bigger, so it says on the top, 9 minus 4 is 5. 31 looks exactly like number 28, so that means we're going to divide our numbers first. 24 divided by 12 is equal to 2, so we know we're going to have a 2. And this is x to the 6 divided by x to the negative 8. That x to the negative 8 does need to move to the top, so we have x to the 6 times x to the positive 8. And that means we will add those together at 6 and 8, so it becomes x to the positive 14. 32 is also very similar, so we're going to have 3 divided by 12. 3 divided by 12 is 1/4. Make sure you check that. 3 over 12 is 1/4. Then we have x squared divided by x to the 6. There's no negatives, that's good. The 6 is bigger. That means we're going to have the x in the denominator. So I'm going to extend that, have x in the denominator. And it's going to be 6 minus 2 is a positive 4. Then we have the y's. Now this y actually needs to move to the bottom as well. So we'll have y cubed and another y cubed. So in the bottom we're going to have a y. We're going to have y cubed and y cubed. That means we're going to do 3 plus 3 is equal to 6. So our answer is 1 over 4x to the 4th, y to the 6th. Number 33, we have a negative exponent on the outside. So what I'm going to do is I'm going to do 33 on the other page. So number 33 states parentheses 2x cubed y to the negative third parentheses raised to the negative second. So number 33, you could actually change this because it has a negative 2. You could actually have a 1 over all of this, and that becomes a positive 2. But I want to show you how to do this by just distributing as well. All of these are raised to the negative 2. So what we can do is have distribute this negative 2 to all the exponents. So we would really have parentheses 2 raised to the negative 2, x raised to the negative 6, and y raised to the positive 6, because a negative 3 times negative 2 is a positive 6. Now, 2 to the negative 2 is actually going to be equal to 1/4. If you plug in 2 raised to the negative 2 is 1/4. The x to the negative 6 needs to move, so that becomes an x, it goes to the bottom. So we're going to have x on the bottom. It's going to be raised to a positive 6 now. And the y was already positive, so it stays on top. Y to the positive 6. So our answer is 1 y to the 6 over 4x to the 6. So we have 1 y to the 6 over 4x to the 6. Number 34. Focus on your numbers. We have 2 divided by 8. 2 divided by 8 is equal to 1/4. We have x to the 4th divided by x to the 7th. The 7 is bigger, so we have x on the bottom. 7 minus 4 is 3, so x cubed. Then we have y to the negative 4 divided by y cubed. That y to the negative 4th has to move to the bottom. So we have y cubed and y to the 4th on the bottom. So y to the 4th and y cubed becomes y to the 7th. So we have 1 over 4x cubed y to the 7th. Now if you look at 35, 36, 37, and 38, they're all fairly large problems. So I'm actually going to do all 4 of these on my other paper so that I can show out all the work for them. So number 35, I'm going to write it out. 35 is parentheses 4x to the 4th, y to the negative 4th, close parentheses, all of that cubed. To do this problem, we do have to distribute the exponent of 3 to each of them. So we have 4, the base of 4 raised to the power of 3, the base of x raised to the power of 12, because we multiply them, then the base of y raised to the power of negative 12. 4 cubed does need to simplify. 4 cubed is equal to 64. X to the 12th can stay as it is, x to the 12th. Y to the negative 12th has to move. That y to the negative 12th is what's attached to that negative 12. So that becomes the denominator of y raised to the positive 12. And I'll put that answer on my paper in just a moment. We're going to go ahead and go down to the next problem, do number 36. 36 is 5x squared y, parentheses, 2x to the 4th, y to the negative 3rd. 5x squared y, parentheses, 2x to the 4th, y to the negative 3rd. There is no exponent on the outside, which is nice. So really what we're doing is we're taking 5x squared y and multiplying it to everything in here. So let's focus on individual parts. So 5 times 2 We're going to do that part first. This is really 5 times 2 times. Then we do our x's. X squared times x to the fourth. We do x raised to the 2 plus 4. Then we do our y's. We have the base of y and 1 plus negative 3. So 5 times 2 is 10. X to the becomes x to the 6th. And then we have y raised to the 1, and then a negative 3 is a negative 2. Y to the negative 2. Now the 10 is simplified, the x to the 6 is simplified, but the y to the negative 2 has to move. So this becomes 10 times x to the 6th divided by y to the 2nd power. And that's our answer. Again, I'll put my answer on my paper in just a moment. Number 37 is parentheses, big parentheses, negative 7 a squared b cubed c to the 0 all over 3 a cubed b to the 4th c to the 3rd, close big parentheses, raised to the negative 4. Now, if we look back at number 33, we had a negative exponent on the outside. I had said that you could actually change this to be 1 over all of that and have a positive 2. But that wasn't exactly the best option because it was a simpler problem. This one, however, has so much in it that we have a negative exponent. We could actually change the numerator and the denominators. We could flip them, and that negative 4 will become a positive 4. That's actually what I'm going to do. So my first step is I'm actually going to make my denominator go to my numerator. So it'll be 3a cubed b to the 4th c cubed all over negative 7a squared b cubed c to the 0, and all of this raised to the positive 4 now. And now I can simplify. Okay, so now I want to simplify the inside of this, and then I'll raise it to the 4th power. So the first part is 3 divided by negative 7. 3 divided by negative 7 is negative 3 over 7. So I'm going to keep negative 3 over 7. Now my negative is technically just out in the front because it's positive divided by negative. It's just a negative. Then we have a's, a cubed and a squared. The a is bigger, so it's going to be a to the 1st power on the top. The b's, b is bigger on the top, so it's going to be b raised to the 4 minus 3 is 1. Then on this problem right here, the c to the 0, that's actually equal to a 1, so that one actually goes away. So we're just left with c to the 3rd on the top. Nothing else with the c is there. And then this is still all raised to the 4th power. Now we have at least simplified the inside, so we have less to multiply, but we do still have to distribute this positive 4 to every exponent. That means also the exponent on the 3 and on the 7. So we really have parentheses. We have that 3 raised to the 4th, a raised to the 4th, b raised to the 4th, c raised to the 12th, all over. And again, we had that negative 7. I did put it out in the front, but that negative 7, it was with the 7, so I'm going to put that negative 7 raised to the 4th. However, just as I said earlier, that the negative has to stay with that 7. I'm going to put negative 7 in parentheses, then raise it to the 4th. Now, 3 to the 4th, we would use our calculator, is 81. So we'd have 81, a to the 4th, b to the 4th, c to the 12th, divided by, now parentheses negative 7 to the 4th is important. You have to have that parentheses. Negative 7, all of negative 7 raised to the 4th power is 2,401. And then we check. So again, we use our calculator. We do parentheses, negative 7, close parentheses, raised to the 4th power, and we get 2401. So do 81 divided by 2401 gives us a decimal. Again, we want to do math, enter, enter. We get 81 over 2401. And that's our answer for number 37. That one was a longer one, which is why I wanted to put it on a different piece of paper. And the last problem is number 38. I'm going to come over here, 38. 38 is big parentheses, negative 2a cubed, b to the second, c to the 0, all over 3a squared, b cubed, c to the 7th, close big parentheses, all raised to the negative 2. So again, we could go ahead and simplify this now, or we could flip it. So it really depends on what makes sense to you. Here, I went ahead and flipped it before I simplified it. I could simplify it first and then flip it. So that's what I'm going to do on this one. I'm going to simplify the inside first and then flip it. So to simplify it first, I have negative 2 over 3, which stays as negative 2 over 3 because in the calculator that won't simplify any further. A cubed divided by a squared is just a on the top, a to the first. B squared over b cubed. The b is bigger on the bottom, so it'll be b on the bottom. 2 and 3, so 3 minus 2 is 1. And then this c to the 0, this c to the 0 again would just be a 1, so that doesn't even count anymore. So c to the 7th is on the bottom, so we keep c to the 7th on the bottom. This is all raised to the negative 2. Now we actually have less to have to flip. So what this does is the numerator and denominator will flip each other, and the negative 2 will turn into a positive 2. So this will switch to parentheses 3b c to the 7th over negative 2a, and this all raised to the positive 2. Now we can actually distribute the 2 to every part of this. So we got to be careful about this because of this negative. So this becomes 3 squared, b squared, c to the 14th, because it's 7 times 2, divided by that negative 2 is squared. So I have to put that parenthesis around that negative 2, and then the a is squared. So 3 squared is 9. B squared, c to the 14th, all over negative 2, all of negative 2 squared is a positive 4, and then we have a to the second. We have one letter A, one letter B, one letter C, and our number is simplified as much as possible. So this is our answer. Now again, what I'm going to do is go back to my paper and make sure I write down the answers for number 35, 36, 37, and 38. So number 35, I'm going to draw an arrow out here so I can write it, was 64x to the 12th divided by y to the 12th. 36 was 10x to the 6th divided by y squared. 37, I'm going to draw an arrow out here, was 81, a to the 4th, b to the 4th, c to the 12th, all of that over 2,401. And then the last question was 9b squared, c to the 14th, all over 4a squared. So these were the practice problems for exponent rules. A lot of them can be done very easily and quickly. Some of them you actually have to show out some work for. So we had on the sheet right here, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 38 problems that you actually had to show work for because these were a little more complicated. But most of the time, the exponent rules, as long as you know your exponent rules, it becomes fairly simple by just following those rules. So make sure you're careful on the rules.